Hi, my name is Wouter Groeneveld, and together with my three colleagues here, Lawrence, Chris and Joost, we explored the role of creativity in software engineering. And I'm super excited to be able to share these results with you guys today. So let's get right into it. But first, let me get my head out of the way. Right, that's much better. Okay, before we dive into the results of what we found, let's first talk a bit about why creativity is so important nowadays. There's a couple of things. First of all, literature says developers also require non-technical skills, besides the obvious technical ones, like for instance knowledge of a certain programming language. Second, expert developers say creativity is important for problem solving. So somehow creativity is one of those non-technical skills. Yet, there's only little published on creativity for software development in software engineering, specifically for software development. So not only for requirements engineering, but we are interested in the whole process of software development, from coding to deployment to fixing bugs and so forth, so everything. Also, we only found less than 5% of the learning outcomes explicitly mention creativity. So that's another research we did. Everything that's on this slide is a reference in the paper itself, if you're interested to find out more about that. Right, so we wondered, what exactly is the role of creativity in the world of software engineering? And furthermore, what makes one developer very creative and the other less so? That's something, well, we wondered, and to be able to answer these questions, we organized 4 different focus groups, and we invited 33 experts to be able to talk a bit about creativity and creative problem solving and how they tackle it in their own job as a software engineer. So the profiles we invited were all technically oriented, and details on the method itself can be found in the paper. Let's not bore you with the details on the methodology itself, and instead let's dive right into the results, which are far more interesting in my humble opinion. Right, so after of course transcribing and coding and cross-referencing everything, we discovered 7 different dimensions of what we call creative problem solving. So instead of just calling it creativity, we went for creative problem solving. Why? Because creativity can be either too narrow or too wide. For instance, if we talk about the Thorne's test of creative thinking, which is one of the most famous ones, that test measures specifically divergent thinking. And we think divergent thinking is indeed one of the assets of creative problem solving, but it's just one. So divergent thinking does not equal creativity, for instance. Furthermore, there are also several personality related tests or papers on creativity, but that's just one aspect of the things we're interested in. So we call it creative problem solving because we're interested in the practicality itself. Right, so 7 dimensions, okay. These are the 7 dimensions. As you can see, let me just move myself a bit around. Let me put myself in the center there. There are creative techniques, technical knowledge, communication constraints, and so forth. We'll talk briefly about each of those, and they're closely linked together, so they're related to each other, of course. To be able to do some critical thinking, you first need to be able to have some knowledge before you are able to think critically about it. If you're not curious, well, you probably won't be picking up any technical knowledge anyway, so they're all intertwined. Okay, so first domain, creative techniques. Creative techniques, really concrete techniques developers seem to be using, such as mapping solutions they come up with from other domains. If they're working on a problem set a year after that, they go back to the related problem in another domain, for instance, another functional domain or another technical domain, such as another programming language, on which they just steal the techniques they used and apply it on the problem at hand. Another example could be employing a bird's eye view, zooming out and then zooming back in, which is more or less the same as exploring different angles of the same solution. And of course, we have the classic brainstorming technique. And these are interesting. Why? Because if we want to teach those to students, well, if students don't know anything about those, for instance, if students don't know how to zoom out or zoom in, or if students don't know anything about brainstorming, they won't be using it. So these techniques can be easily explained and afterwards used. Second one, technical knowledge, speaks for itself. Of course, everyone needs knowledge on certain programming frameworks, certain trends in software development. You need to be able to continuously learn stuff. One participant summarized these things succulently. He said, creativity is the brew of different inputs. If you don't have any inputs, you can mix and match those and you can be creative. So that was really interesting. And also it's related to the domain model if you're working at a functional domain. Third aspect is communication. Communication is one of the aspects of creative problem solving, not only in our view, but also in the view of our experts we talked about, because if you don't work together, you don't get new ideas and they're not shared. It's sort of like a liquid network you're in. The fast feedback loop could be an important one, and of course also the shared responsibility. Constraints, another one. Sometimes a constraint helps you to be more creative instead of being less creative, but it's not always needed. The context is really relevant here. Then we have, of course, critical thinking. Instead of just looking up something on Stack Overflow and just copy pasting, you first need to be able to interpret the results and what is being said, and maybe come up with alternatives for yourself. Curiosity, you need to be able to get out of your comfort zone, is what people said. Maybe also convince others to get out of their comfort zone. It's closely related to motivation. Some participants called it the creative urge, the urge to develop something new, the urge to be able to get out of that comfort zone. I think it's something that can be taught. Initially, if you're not really comfortable, once you see the advantages of it, it's really a powerful aspect of creative problem solving. Next, we have creative state of mind. What's that? Well, it's closely related to flow or focus. If you're programming away and the time is flowing and you're like, oh my gosh, it's the end of the day already. Wow, we did so many interesting things today. But there are other days maybe that you see every second passing by. So that's not really flow or focus. And it's closely related to the environment you're in, the colleagues you're in. So it also has that social aspect. And of course, you can also use productivity tools to be able to get in that flow faster. So, okay, these are the 7 domains, really fastly explained. But of course, this paper is not without its limitations. We still don't have any unifying definition of creativity, but that wasn't our focus. We just wanted to explore what creativity is about in the world of software engineering for software developers. Furthermore, we also found out that it's very context dependent. So in one focus group at one firm or one company, they would say something completely different than the other company, because maybe the company culture was also one of the determinants of how they think about creative problem solving. And also we wondered, are only creative people interested in focus groups on creativity? We invited participants, but of course we didn't oblige anyone, so maybe the ones that didn't join were also had an interesting thing to say about it, and we didn't get that. So what's the next step? Well, we intend to use these results, these 7 domains, to be able to measure creativity. Our ultimate goal is to introduce more creativity awareness in the curriculum. So we want to teach the students how to be able to creatively solve something. So we first want to develop a survey, then we can somehow use these metrics to enhance and monitor the students' creativity itself. That's our next big thing to do. All right. To conclude, that's what we did. We invited 32 different experts and brainstormed about creativity in 4 focus groups, and we invited those guys and they thought about creativity, and that means that we identified 7 distinct teams. Right. Thank you. Thank you.
Hi, everybody again. So we are ready to enter the Q&A session. Walter Gronowell is with us, and well, we are ready to take profit of this 9 and oh no, it's only 5 minutes because it's a short paper. Probably I don't know. It's just the half time. So first question, Walter, is okay. You talk about 7 dimensions of creative problem solving.
Yeah.
Creative techniques, technical knowledge, communication, constraints, critical thinking, curiosity, creative state of mind. What is really a good point, but how to assess the conceptual completeness for the concept? Why these 7 and not 6 or 8? Any clarification about this aspect?
Well, that was the outcome of what we did with our methodology, which was a focus group, and we organized 4 different focus groups. And I'm pretty sure that if we went to other companies that did not focus on software engineering, but for instance on software requirements or something else, that maybe there would be a possibility for another dimension to appear. So that is indeed a possibility. But what we did is we analyzed all the transcripts, and there were different coding steps. So details about that are in the paper, and that was the result. And we also took a good look at the existing works in literature. So we think we were as complete as possible with these 7 dimensions.
Okay, in this direction, there is a question from Alexander Serebrenik, that is, to what extent are these 7 domains specific for software engineers? Mm-hmm. After all, creative problem solving is not so new, and many topics you mentioned seem to be relevant for other engineering disciplines.
Yes. I think that's a really intriguing question, and we're still asking ourselves that and trying to answer that question. I think in the coming years, there's a lot of work to be done to be able to correctly answer that, because we went to software engineers and we asked, what do you guys do to be creative? And the answer indeed is surprisingly general, in the sense that also a mechanical engineer could answer something like that. But for it to be specific to software engineering is a quick evolving field. Every few months there's a new framework or a new library appearing. So people need to be able to adapt more quickly than in other fields. But well, that's also discussable, of course. But the point is, we organized focus groups within software engineers. So experts, software engineering experts answered these things. And these 7 domains came out of that. But indeed, the next step to make, or the next question to ask, is to what extent are 1 or 2 or 3 or even all 7 dimensions also applicable in other fields? So to be able to answer a question, I think I need 1 more year of work. Sorry to disappoint.
Okay, thank you. So we have more questions than time. There is a question from Madeline. What are the most common methods you saw people indicate that they use to get into a creative state of mind?
I think one of the most underappreciated things, which is a bit more mundane than all the other fancy things, is just stand up and ask a colleague. Because usually when you're working on a problem, you have this narrow field of vision and you're hammering away and banging your head against the wall. And then when you ask someone else, what do you think? And they say maybe this or this or this or that. Then you broaden, you widen up the area, your thinking view. And so it's the interactive part of collaborative problem solving, which is also creative, I think, in my opinion.
Okay, a very short question for this. Very short answer for this question. Do you have any statistics on how many for each criteria?
Not really in that sense, because it was not really a quantitative study. It was a qualitative study. So I think we have some numbers, but they're more like the amount of codes that appeared in the transcripts themselves. But for only 30 to 40 participants, I don't really think they're that statistical.
Okay, so 15 seconds to say thanks to everybody. Thank you very much, Walter. You have now you can continue the discussion in the room that is assigned to this paper. Thank you, Natalia, for clarifying that these papers have 5 minutes. And well, I want to say goodbye in time. Thank you, everybody.